Hello and welcome to the first tutorial in the Python for Beginners course. This is a very beginner-friendly 101 course. In fact, we're going to start with installing Python on a Linux Debian distribution. Let's go into the terminal. If you've watched any of my previous tutorials, you'll probably gather that I am a Docker fanboy. And what I've done here is I've just created a very basic Docker container for us to use in this Python course. I've left the commands up here if you want to pause the video just to find out how to start a container and so forth. And just to show you that this Docker image was created 8 months ago, so it is fairly out of date. And so the first thing I need to do, of course, is to update all of my sources and all of my packages to ensure that I have everything up to date. And then what I'm going to do is install Python. So the first thing I'm going to do is just type apt and then -get, do an update, and then press enter. That's going to just flick through all the bits and pieces. This might take a little bit of time. Now, as this is going, I'll talk about Python in a little bit more general of a sense. So Python has two kind of modes, if you will. One is an interactive mode and the other is a scripted mode. We'll be showing you how to do those throughout the course and what the difference is between the two. Now everything has been updated, we can upgrade those packages. So let's do an apt-get and this time do an upgrade. And that's going to upgrade the packages. It's going to ask us whether or not we wish to upgrade. Just type Y or just press enter, and that will upgrade all the bits and pieces that were listed above. Now all of those packages have been upgraded. It's now time to install Python. And in this course, what we're going to be focusing on is Python 3. Now to install Python 3, you simply type apt and then -get space install, that's the install command, and then another space, and then you type in the package that you wish to install. In this case, it is just Python and 3. So there's no space, there's no hyphen here, it is just literally Python 3. Press enter and it's going to find that package. It's then going to ask you to install all of the dependencies of that package. So here we can see we have Python 3.5, Python 3.5 minimal, and it has some MIME support, DH Python, and so forth. We've even got SQLite if we need it too. And it's also going to suggest some packages as well that we can install if we wish. But for now, let's just type Y or press enter, and that's going to just install the packages that were listed there. Now we're going to focus on Python 3 in this course simply because it is the latest and greatest. But there are obviously a lot of systems out there that are running on legacy versions of Python, and we will be talking about those in future courses, so not particularly in this course. So this course is, like I mentioned, specifically for Python 3. So we've just installed Python 3, Python 3.5 to be exact, and to ensure that that has actually installed and we have the correct version, what you can do is type Python like so, and then 3, again no spaces, no dashes, press the space bar and then do a hyphen, and you got to ensure that this is a capital V. Press enter and you'll get Python 3.5, and in this case it's 3.5.2. Now Python isn't the only thing that we need to install. If you think about all the other programming languages out there, they all, or most of them, have their way of downloading dependencies and packages, and that's no different for Python. Python has a pip, which is the Python package index. So we need to install pip, and we do that by installing another package on this Ubuntu system, much like how we've installed Python 3. So it simply is apt and then -get install. You type in the package name, which is Python 3, and then -pip, PIP. Press enter and that will list all of the packages that depend on pip, and it will also offer you some other suggestions of packages as well. Just press spacebar or enter to install pip, and this, as you can tell, is a large amount of stuff, so I'll skip over this just to get to the end. And like I've mentioned, pip allows us to download packages from the index. So for example, if I wanted to download Flask, I would simply type pip and then 3 and then install passing in the package that I wish to install. So, for example, Flask, for example. Then press enter, and that will download Flask and all of the Flask's dependencies. And we can see that the pip version 8.1.1 is being used. However, 9.0.3 is available. We'll talk about all of this in later parts of the course. But it's also installed other things like Makeup Safe and Click and all sorts of other bits and pieces as well. So that was how to install Python 3 and pip on a Ubuntu server. Now, the commands are very similar if you're using a different distribution of Linux. Obviously, the package manager that you're going to be using may be different, so you might be doing different commands to install those things, but the actual structure of installing Python 3 is very similar to what I've demonstrated here. Obviously, if you're using another operating system that isn't Linux, so for example Windows, then it is a different story. And what we're going to do in this course is focus, like I said, on beginner-friendly stuff. So the next part is going to be all about the interactive shell, then how to use the scripted mode of Python as well. If you've got any questions on anything that I've demonstrated today or in any other of my tutorials, or if you have some suggestions on what you would like to see in this course, then do let me know. Put them down in the comment section below. Thanks ever so much for watching, everyone. Happy coding. I'll see you again soon. Cheers. Bye. Hello and welcome to the second part of the Python for Beginners course. Today we're going to be focusing on the interactive shell. This is the interpreter of Python. This will allow you to actually write Python code in the command line. So it's not the scripting mode where you can actually write to a Python file and run that. This is the interactive shell. So let's dive straight into the terminal again, and this is basically where we left off before. So this is where I was actually installing all the bits and pieces for Python. What we're going to do is just clear down the screen just so we can have a bit of playground room. So the first thing to show is how to actually get into the interactive mode of Python. Let's just type Python here, and it's just Python 3. If you press enter, there you go. You are straight into the interpreter. You can see that by the three arrow symbols at the start of the prompt here. That means that you are in the interpreter. Now, here we can see that you can type help and copyright and credits and license and so forth to get more information. The help method is something that we can actually use to pass in an object or a string, if we wish, to get help about that particular thing. So, for example, if I typed in help here and then put in some parentheses, and inside those parentheses I put in, say, a list or a dictionary or even a string, then it will show me about that particular object or string. So, for example, if I was to type in list like so, we can get all of the bits and pieces that define that list. So, for example, we know that it is iterable. So up here, it is an iterable. We know that we can create a new list by just typing in a list with a parentheses as empty. We know that we can add things to the list. We can check whether things are contained within a list. We can delete items, we can equate items, we can get an item, and so on and so forth. So it's a great way of discovering what you can and cannot do with some of these Python methods, functions, objects, and what have you. Now you can see that there is more, and if we press spacebar, we can see that we can scroll all the way down to the bottom. So there's other bits and pieces, so we can even sort and we can get the reverse of the list and so forth. These are methods upon the list that you can create. Now I mentioned that you can also pass in a string as well. So for example, if I typed in help and then in the parentheses pass in something like print, for instance, it will find me information about the print method. So here it's printing values to the stream and so on and so forth. If, however, I did something else, I did help and then passed in something that didn't exist, so for example foo and then bar, that will throw an error because there is no documentation of foo bar, because foo bar doesn't really exist. So when I said that it can print out strings, what I meant was it prints out the representation of what that string is. So for instance, if it's the name of an object or a method, then it will get the information about that for you. So just any other random string that just doesn't represent any kind of method or object or whatever, then that will throw up this error. So it will say no documentation found for foobar. But what happens if you don't pass any arguments to help? Let's try that. So type help and then just an empty set of parentheses. Press enter and you can see that we've actually gone in to an interpreter, if you will, of help, which means that we can use help directly now. We don't have to type in the help method. We can now do, for instance, list like so, and that will get the same thing as we had before. Now, one thing that is really useful with this help method is that it can pull out specific parts of, say, an object. If it's a specific method that you want to just find out information about, you don't have to go through all of the documentation just to find out. Let's say, for example, we wanted to get to the last method here, which was sort, and we would have to scroll through all of this. We can literally just do list and then dot and then sort, and that will just pull out the specific information for that particular method. Of course, if we typed list and then foobar again, that's going to throw an error because foobar doesn't exist. There's no documentation found for foobar. Now, this is why I really like Python, because the documentation is right there for you. You can just jump in and find out snippets of information for bits and pieces. So it's extremely user-friendly. Now, to come out of the help utility, simply type quit and you're back to the normal command prompt, which is the 3 arrows. So we're still in the Python interpreter. All we've done is just come out of the help utility. So that is how you can use the Python interpreter to discover things about Python methods, Python objects, and so on and so forth, using the help utility. I use this, like I said, all the time because it is extremely handy just to find argument signatures and stuff like that around methods, and also to discover methods that I just wasn't even aware of. So do use the help utility. It is a very powerful thing. If you've got any comments, questions, or queries on this course, or if you've got suggestions for future parts to these tutorials, then do let me know. Put them down in the comments section below, and if you haven't done so already, please do subscribe, because I've got a tutorial like this every Tuesday, and then on the Friday show, we actually talk about software development, web development, and so forth. Thanks ever so much for watching. Happy coding. I'll see you again soon. Cheers. Bye. In this Python for Beginners tutorial, we're going to be looking at the formatting of Python code, because it is quite different to other programming languages. For a start, it uses indentation as a means of reading and parsing the actual Python code. So, for instance, with other programming languages, you might have a curly brace that denotes the start of the body of a function or a method or a class and so forth. For instance, JavaScript or PHP. Whereas this, it's actually using indentation to do that. So let's dive straight into the tutorial, and I'll demonstrate what I mean in just a second. So what we need to do, of course, is actually build a very simple application to prove that indentation is a very important part of Python. So we're going to write some very simple Python code, and I'm going to be explaining all of these bits and pieces in far more detail later on in this course. But for now, though, we're going to dive straight in and create our first variable. So this variable is just going to be foo and then bar, like so. We're going to equal that to the value of true. Now, that is a Boolean, and I'll discuss all about data types later on in this course, but essentially that is either going to be true or it's going to be false. Think of binary, 0 or 1, that kind of thing. So press enter, and what we've done is we've assigned that variable, which is called foobar, to the value of true. The next thing we're going to do is just create a very simple if statement. Now, if the statement is true or if it is false, then we can change the behavior of the application. This is what's called a control flow. I've done a whole tutorial series on control flows for PHP. I'll certainly be doing a bunch of tutorials on control flows for Python. But for now, though, we're just going to dive straight in and create the first if condition. So type if and then a space. We're going to have foobar because that's the variable that we wish to check. And what we're doing is we're checking that that value is true. So if foobar. Now, the next thing we would normally do in other languages is perhaps put this in some parentheses, and we may have some curly braces to tell the application that that is an if statement and that anything in the body of those curly braces actually do something. But Python, like I've mentioned, is slightly different. Instead of curly braces, instead of parentheses, what we need to do is put in a colon like so. We also need to press enter, and notice that instead of the 3 arrows in the prompt, we now have 3 dots like so. This means that we are starting the internals of this if statement. We need to actually fill out the block which is running if foobar is true. Now, if I want to run some code in this if block, if the foobar variable is true, so if I was to do print and then let's just print out in standard output hello and then world like so, and press enter, we're actually going to get an error. And we're going to get an indentation error. So if I press enter here, we can see that we have this indentation error, expected an indentated block. This is because we are within, or we're trying to be within, a if statement. Like I said, Python needs indentation to define the various blocks within the Python code. And the block that we're in is within the if statement. So let's just press up on the keyboard a bit so we get to the if foobar. Let's press enter. So we now are back to where we were with the 3 dots. Let's now just press tab. Now that's going to create ourselves an indentated block. So any code that we write in here will be executed as a block within this if statement. So let's just type print and then the string of hello world again, like so, and that will now provide us with another set of 3 dots. And this is because, of course, you can have more than one line in the block of your if statement. But if we press enter again, what we're doing is we're closing that indentated block, and therefore the application is going to run and we get hello world. Now, why did we get hello world? Well, that's because what we did up here is we set foobar to be true. We're then equating that, we're saying if foobar, so that will be true, so that will run. We then print out the string hello world. Of course, with if statements, you can also have else blocks as well, which is something that we're going to be looking at now. So let's type in if foobar again, and remember to put in the colon. That's going to bring us into this block, which we need to press tab to indentate the block. Let's just type print, and in the parentheses, type the string of foobar is true, like so. Make sure you have single quotes either side. Press enter, and then what we're going to do is type else. And notice that I haven't indentated this block yet. It doesn't need to be, because it needs to be in the same indentation as the if statement. Okay, so else and if need to be on the same indentation. So else, and then we're going to press enter here, and now we can actually work within this else block. So press tab to work within it, type print, and then the string here is foobar is false, like so. Whoops, like so. Remember to close the string and close the parentheses, press enter again, and here we can see that foobar is true. That is the output that we've got. And again, that's happened because foobar we set that as true up here, and therefore if foobar, this part of the code will run. This part of the code won't run because this is saying that this will only run if foobar isn't true. Okay, so if foobar, then we run this code, else we run this code. Foobar is true, and therefore that is ran. So what do you think happens if I was to set foobar, let's just press up a couple of times on here, foobar to be false, like so. Press enter, and then let's just type if foobar again, like this, and then put in a tab, print, and then foobar is true, so it's as it was, and then type else, and then put in another block here. We're going to print, and then it's foobar is false, like so. If we do that, press enter and enter again, we're going to see foobar is false. And that is because the variable value of foobar has been set to false, and we basically overwritten it. So the foobar originally was set to true, and therefore we were getting this out here, which was foobar is true. But now we've set foobar to be false, and therefore we are now within this portion of the if statement, because this is not going to equate to true, because if foobar is set to false. Now I'm going to be focusing on the various data types that we can use with our variables. So for instance, integers, floating points, lists, tuples, dictionaries, strings, what have you. All of that kind of stuff is coming up. And also we're going to be taking a longer look into control flows. So not only are we going to be focusing on if statements, but we're also going to be looking at how to loop over various lists of items and things like that in the future. So if you haven't done so already, please do subscribe, because I have tutorials like this and also weekly software development discussions as well. If you found this tutorial helpful, if you've got any questions or comments or queries, then do let me know. Put your thoughts down in the comments section below, and also if you've got any suggestions for future tutorials as well. Thanks ever so much for watching. Happy coding, everyone. I'll see you again soon. Cheers. Bye. In today's Python for Beginners tutorial, we're going to be taking a look at how we can actually create a Python file and run that as a Python application. So we're going to be using the similar stuff that we did in the last tutorial with the if statement, but we're actually going to create a file and we're going to run that like a Python application. So let's dive straight back into the terminal here. This is basically where we left off last time. So we have the foobar is equal to false, and then a simple if else statement. What I'm going to do is I'm just going to copy all of that into the clipboard here, and I'm going to come straight out of this interactive shell. So press Control C to come out of all of that stuff. What we're going to do is discover where Python lives as a binary on this Ubuntu system that I have here. An easy way to do this is just type where is and then a space and then put in Python 3 like so, and we're going to have a whole bunch of bits and pieces about where Python 3 lives. Here we've got user bin Python 3, that's pretty good. We also have user lib, we've got other bits and pieces as well. We've also got it in etc. This is probably where we're going to be focusing, the user bin. Now we need to create the Python file that will hold our application. So I don't know yet if there is vim on here. There isn't. Maybe there is nano. Let's just double check. No, there isn't, so bear with me a minute. Let's just do an apt-get install of Vim just to install an editor for me. So here we go. I should have checked that that was in before, beg your pardon. Put in some clear just to get some room. So now we can type VI, or if you're using Nano, use Nano, or even if it is just a basic text editor, then use that too. But for me, I'm going to put in VI, put in the name of the file, And what I like doing, you don't have to do it, but what I like doing is having the extension of .py because that denotes that you are using a Python file. So let's just type in foobar like that, because that is the name of a file, and then the extension of p and then y. Okay, so we're in VI or Vim, and what I'm going to do is just go straight into the interactive mode. So what I've just done is I've pasted the stuff that we were doing in the last tutorial into this file. Now what I've done is I've added a new line to the top of this file, and that will be used to interpret how the operating system should run this file. So we're going to add the path to the Python binary that we found from the where is command that we had last time. What we need to start this file off with is a hash and then a bang and then the path of that executable file. So put in a hash symbol like so, and then a bang, which is an exclamation mark. The next thing I'm going to do is just simply paste in the path to the Python 3 binary that we have here, which in my case is on user bin path, but like I mentioned before, this could be a completely different path to what you're using. Now this has to be the very first line of the file, because this is telling the operating system when it runs this file that it should be ran by Python 3. After you've added the path to the Python 3 binary, you need to add a new line between that path and the actual application itself. So just press enter here. Now this will be translated slightly differently depending on what type of operating system you're using. So if you're using a Windows operating system, you need to ensure that perhaps it needs to have \r\n, whereas if you're on a Unix style operating system like this, which is Ubuntu, then you just have to have \n. Don't worry about that too much. Just have in a new line like this. Normally you're fine. But if you aren't fine, if you have a problem with this file running, usually it means that this part of the application hasn't been set up correctly. Okay, so what we're going to do now is we're going to come out of this editor and we're going to have to set the permissions of this file to allow it to actually be executed. So what we've done here is we've defined how it's going to be executed. Now we have to make it executable. So let's come out of here. I'm just going to write and quit this file like so, and we've got foobar.py. If I was just to type in ls, we should have that here with everything else. So we need to make that executable. And if you have seen my Linux Bash for Beginners course, then you'll know that we need to change the mask of that file to allow us, the user, to have executable rights. So we do this by doing a chmod, because this will modify the file's permissions, and we need to have a +x because we are giving executable rights to the current user of this system. Now let's put in the path of the file, so we can just put in foobar.py, press enter. You won't get any output here, but you've made that executable. Next, what we can do is actually run the file. So put in a period and a slash and then the name of the file, which is just foobar.py. Press enter and we have foobar is false, which of course is the output of our application, because we're falling back into the else part of that if condition. So let's go back into that file and change that up again. So let's do a VI again of foobar, and what I'm going to do is I'm going to just change that from false to be true like so, and then I'm just going to come out of this and write and quit. That's fine. Run the file again, and this time foobar is true, because now we're in the top half of the if condition. Because foobar is true, we're no longer in the else block of the if condition. That is true, and therefore that is running. I'm just going to bring the file up again just to show you what has happened. So beforehand, foobar was set to false, and therefore we're in here. But now it's set to true, which means that this condition is now correct, which means we're here. So this is being printed out to the screen. So that was the first scripting example in this Python for Beginners course. We're going to be looking more into scripting later on in these tutorials, and we're going to be using different tools and things as well too. But if you've got any comments, questions or queries on this tutorial or any tutorials that I have done, or if you've got suggestions for future tutorials, then let me know. Put them down in the comments section below. I do read all of your comments. I do appreciate it. If you haven't done so already, please do subscribe, because not only do we do tutorials, but we also do discussions about software development. Thanks ever so much for watching. Happy coding, everyone. I'll see you again soon. Cheers. Bye. Hello and welcome to the next part of the Python for Beginners course. In this tutorial, we're going to be focusing on Python variables. But before we delve into any of that, I just want to say that Python is pretty much all object orientated. So everything is basically an object, and therefore you can call methods on the objects and so forth. Now, we're not going to be focusing too much in the object orientation of Python in this tutorial, although we are going to be looking at that in future parts of this course. But just know that everything that you do is basically like creating an object, and then you can call methods upon that object. Now, where does that fit with variables? Well, with Python, variables aren't strictly typed, and therefore you don't have to declare the type of variable before you use them. However, when you have a variable that is a string, you can then do things on that string, or if that variable was a number, you could do things on that number. Same as if it was a list, you can do things to the list, you can sort the list, you can add things to the list, you can remove things from the list, and so forth, like you would call a method on an object. So that's basically the first point that I would like to make. It is not strictly typed. You do not have to say that this variable is going to be a string. It will work that out for you. So we're going to dive straight back into the terminal now, and we're going to start creating our own variables. Now we're going to be doing this directly into the Python interpreter. So we are in the console here. So we've started off with Python 3, which means that we are in the command line. We can see that we have started this with the 3 arrows like so. Now, you've seen me create variables before in the previous tutorials where we have foobar and we set that to a boolean, which is either true or false. Of course, there's other types of variables that we can use. We can create lists, we can create strings, and we can create all sorts of other things, including different types of numbers as well. We're going to be looking at a few of those today. Because Python isn't strictly typed, we can literally create a variable by defining the variable name and then equating that or assigning that to the value. And of course, that value can have a different type. It could be a number, it could be a float, it could be a string, and so on and so forth. Let's just, first of all, let's create a simple string. So first of all, just do a variable name, and we're just going to set that as test. Now we need to do a space and then an equal symbol and then another space, and then we equate that to the value of the variable. In this case, because it is a string, it needs to be in quotes. So we're going to have this is a string like so. Very basic. Now we close the quotes off. Now in other languages, you might start to create a variable by using the term of var. So var and then the variable name and then its value, like JavaScript. But we don't have to do this here. It is just literally the name of the variable and then its assignment. So here we're saying that the variable name is test and we're equaling that to the string, and because it's in quotes, it is therefore a string. This is a string. And also, we don't have to have any kind of semiquote or any kind of ending thing to denote that this is a variable right at the end. It is just like this. And of course, if we press enter here, we have now created that variable and assigned it that value. So let's go ahead and print that out. And again, we can use the print method here, so print and then putting in the variable name, and if we press enter, we have the output of that variable, which is this is a string. So let's go ahead and create a number. So let's do test and then 1, equate that to the number of 45. Press enter here and we have created that variable. Again, if I was to type print and then in the parentheses put in test and then 1, we have 45. Now we've still got the first variable test already in memory, and if I was to just do print and then test again, we can see that that is already stored. However, we can redefine that, we can reassign that to another variable value. So for instance, we can do test now is equal to 52 and then press enter, and then if I was to print that out again, so print test, this is now no longer is it going to be this is a test, no longer is it a string, it is now the value of 52. So we've changed the type of the variable from a string to a number. Now we've got two numbers, we've got test and test1. What we can do is add those numbers together. So what we could do is test2 is equal to test1 plus test, and then press enter and then do a print of test2, and that should be the output of both of those numbers combined. So we've done an addition, we've done some mathematics on that. So first of all, we had the test, which was a string, then we have another variable which is test1, which is a number, and then what we did is we redefined the first variable, the test variable, as a number, and then we added that to the second variable whilst creating a third variable which is test2. So you can see that you can build variables up like this. Now these numbers are of course integers because they are whole numbers, but of course we can also use floating points as well. These are decimal places. So for example, we could now do test2 is equal to let's do 13.54 for instance. Press enter and print that out as test2, so we've gone and redefined what that variable is, and that's now 13.54. So that is a floating point. It's not an integer because it's not a whole number. Now with strings, you define that of course using the quotes, and what I've done up here is I've got two single quotes, one on either side of the string. However, like other programming languages, you can also use double quotes, so you don't have to have single quotes. What I would recommend though is whatever you choose to use, you use that throughout your application because it will just be easier to read when you're just glancing at code. Don't have a mix of single quotes and double quotes in your variables. Also, what you can't do is you can't have a single quote at the start and a double quote at the end, or vice versa. You have to keep it nice and consistent. So if you're starting a variable with a single quote, you must end that variable value with a single quote too, and also with double quotes. So for instance, test2, let's just make that a string, but this time we're going to use double quotes. So here we're just going to do this is a test, like so. And then if we did a print of test2 like so, we've got this as a value, but let's for argument's sake change the end quote to a single quote. Press enter. We're going to get an error, and that is because we have a problem with the end of line where it's scanning a string literal. One of the benefits of using double quotes instead of single quotes is of course the fact that you can use single quotes within the value of the variable. For instance, we might want to have a string that includes apostrophes. Now, the program will interpret an apostrophe as a single quote unless it is within double quotes. So for instance, we could have test and then 2 is equal to double quotes, this isn't, putting in a single quote as the apostrophe, this isn't a number, like so. Press enter, and that is a correct assignment of that variable value. Even though we've added a single quote here, that is an apostrophe because it is in double quotes. Now, if we were to do this the other way around, we would then break out of the variable assignment, and then we would have an issue. You'd have to escape that. We might look at that later on in other tutorials. But if I was just to print this out again, just to show you, so print of test 2, we now have this isn't a number, and the output of that hasn't been affected, even though we have a single quote as the apostrophe in the word isn't. Now, one thing I really do like with Python is the fact that it allows you to have multiple assignments all on one line. Some people don't like that because maybe it's a bit difficult to read. However, if you don't have a lot of assignments and you're just assigning them to very small variables or even objects that we're going to get onto later on, then it's actually quite nice to do. So to do this, what you would do is you would have A, comma, B, comma, C. Okay, so we have 3 variable names. So we can now equate those variables to their designated values. So we have an equals sign here, and then after the equals sign we have the same amount of values to the variables that we have defined. So for example, here we have 3, and therefore we need to have 3 values. So in this case we could do 1 and then foo bar and then 2, like so. So what we're doing is we're assigning these 3 variable names to these 3 variable values. So A is going to be set to 1, B is going to be set to foobar, and C is going to be set to 2. Yes, so if I press enter here, we've now created on the fly 3 variables and we've assigned them their particular values. Now notice that A and C are both integers. They are set to 1 and 2 respectively. B, on the other hand, is a string. What do you think is going to happen if I try and add all of them together? What do you think happens when you try and add an integer to a string and then to another integer? So let's try this out. Let's do test 3 is equal to A plus B plus C and press enter here. Now we have an error. It's because we have an unsupported operand. What does that mean? Well, when we're doing the pluses and the minuses, they are the operators. We are operating upon the variables. So we are adding, we are subtracting, we are multiplying, we are comparing, we're doing greater than, less than, that kind of thing. We can't do that with an integer and a string. You cannot add an integer to a string or a string to an integer and so forth. So here we're saying that we can't add an int to a string. Str, str means string, int means int. So even though Python isn't strictly typed, Python certainly knows what type of variables you have defined, and therefore it knows what variables can be operated on when in conjunction with other variables. And I must say this is fantastic because in other languages this isn't handled so well, and in fact if you go and try and add 2 data types together, then you get a completely different data type in some languages, JavaScript. But you know, this is Python and it's a breath of fresh air. At the start of this tutorial, I mentioned that Python is very object-orientated. Even though we've created variables such as strings and integers and floating points today, we're actually creating objects, and therefore we can call methods upon those objects. So the strings that we created, we can call methods upon those. The integers that we created, they also have methods that we have available to us as well. What do I mean by this? Well, let's go and create a new variable, which is a string. So let's do test 4 is equal to, this is a string again, right? Press enter to set that. Now, at the moment, as you can see, this string isn't capitalized. It's all lowercase. So this starts with a lowercase t. How would we go about capitalizing that? Well, in some other languages what you would do is you would perhaps run it through a function or some sort of method against something else. Well, in fact, with Python, this variable test4 is an object of the type string, and therefore we can call all sorts of methods that are in the string object. So let's go ahead and call a method that will capitalize the string of test4. So what we do is type test4 like this, and now what we need to do is call upon a method of the string object, and we do this by putting in a dot or a period symbol like so, and that means that we are about to call a method on that object. And remember, this object is a string, so any method, any string method, is now available to us. But again, how do we find this? Well, if you just press tab a couple of times, you can see a complete output of all of the methods available to us. So we have, for instance, capitalize, which is the one we're going to use in a minute. We have count, so we can actually count the amount of characters in the string. And we also have lower, and we also have upper. These might sound very familiar if you've come from PHP. And what you can do is call upon those methods to alter the variable that is the object. So for example here, let's do capitalize. So let's just copy that like so and put that in. It's a method, so you have to call it like so with the parentheses, press enter, and we have the output. But notice that this is a string again, starts with a capital T, whereas up here we set it to a lowercase t. So any kind of method that we've got here, notice we have replace, and we have splits and strips and all sorts of bits and pieces, or very interesting things that we can do to manipulate strings are available to us. Now, let's say, for example, there is another method that we want beginning with C. So what we do is, let's just go up here, remove that. Let's just put in C and then press tab a few times. This is an extremely useful way of discovering what is available to you in Python. Now, we have literally just scraped the surface of Python, and throughout this course we're going to be focusing even more on different types of variables and how we can manipulate those variables through the object methods later on in this course. But if you found this useful, if you found this helpful, then do let me know. If you've got any questions, comments or queries, put them down in the comments section below. Also, if you've got suggestions for future parts of this course or other courses that I do. If you haven't done so already, please do subscribe, because I have a tutorial like this every Tuesday, and also a discussion on software development every week. Thank you ever so much for watching. Happy coding, everyone. I'll see you again soon. Cheers. Bye. In today's Python for Beginners tutorial, we're going to be looking at the difference between tuples, lists, and dictionaries. Now, these are ways of storing a collection of data in Python. They all have their pros, they all have their cons. We're going to explain each one in turn in today's tutorial. Before we dive right into the terminal and start writing some code, let's just talk about each one. Now, a list is what it sounds like. It is a list of data, and that data is indexed from 0 to 1. So you would have like a key and a value, key value pair, where the key is a numeric number from 0, and the value is obviously the value in the list that you wish to store. Now, lists are changeable. You can create a list and you can add items to that list. You can also modify items in the list and remove items from the list. Therefore, lists are very useful to use when storing data that changes quite often. Tuples, on the other hand, are like lists. However, you just can't change the data, the values in the tuple. Once you've defined them, you cannot change them. So, for example, this is very handy if you're having a list of, say, months of the year, because they don't change very often, obviously. Now, items stored in a tuple are very similar to items stored in a list in the sense that they are indexed by numbers. However, this differs from the dictionary, because a dictionary it's basically what it sounds like. It is an index of words. So the index being the keys, they are not numeric. They are actually words. They're text. So where we have key and value pair in the list and the tuples, they would have their indexes as numeric, whereas in this case, you're actually putting in text. So you have a text for the key, and then the value can be whatever it needs to be. This means that the items in the dictionary aren't really in any particular order. They're not ordered by numeric numbers because they're not numbers. And so there is an element of flexibility in adding keys and values in a dictionary. So where would you have a list, where would you have a tuple, and where would you have a dictionary? What's the point in having the three of them? Well, if you think about some things that just never change, so for example, the months of the year, or the seasons, or the names of certain events that happen during the year, like Christmas and Easter and all of that stuff, they don't change, right? So you could create a tuple of those events. So, for example, you know that Christmas is probably right at the end of the year, so that would have the highest number in its index, and its value would be Christmas. And because it's a tuple, it means that you cannot change that in the application. It's not changeable. When you're using tuples, you are essentially saying that this variable cannot be changed. Once it's been set, it has been set. And that is laying down some rules for your application, which is a good thing. Lists, of course, can be modified and changed, and they are also indexed from 0 and then upwards. So you could have perhaps a list of names or a list of places and all of that kind of thing. So when you're building up a list, when you want to have a list that you can add to or remove from and have that in numeric index, then use a list. A list is very good for those kind of things. And of course, dictionaries are indexed by text, as I've mentioned, and also they're not sorted in any particular order. So they're very good for things like configuration or anything that you want to add to your system and modify, but have a textual based way of getting hold of that piece of information from your variable. So let's go and dive into the terminal now and actually start building some of these things. So we're in the Python command line here, and what we're going to do is first build a tuple. So let's just go and create ourselves a variable. We're just going to call this test1, and we're going to equal that to our tuple. Now, you can do this in a couple of ways. A tuple could be in brackets like so, and then you would divide each one up. Each item you would have as perhaps a string like this. So here we could have foo, here we could have bar, here we could have the number of 3, and then 4, and then 18, that kind of thing. Pressing enter, that means that we have now defined that tuple. So test1 is a tuple where the first item has a value of foo, its index is 0. The second is bar, third is 3, 4, and then 18, and so forth. But as I said, these are indexed from 0, so that would be 0, 1, 2, 3, and 4. Because we've created a tuple, we can call methods on the tuple object, and we can discover bits and pieces about the tuple that we've created. So for example, if I put in test1 and then the method of count, this is going to count how many items have the value in this tuple. So for instance, if I was to put in bar here, we should get 1, which is true. And also if I pressed up on here and put in foo, we should also have 1. Why is that? Well, this is because it's saying that there is only one value of foo and there is only one value of bar in this tuple. Let's go and create a new tuple now and have multiple values which are the same. So for example, let's do test2. We're going to equal this to another tuple. Now, before I do this though, I should mention that you don't have to use brackets. You don't have to open and close brackets when you're creating a tuple. However, it can be easier to just read that that is a tuple if you have brackets. If you don't have brackets, you can simply just put in foo and then a comma and then bar, and then let's do another bar, so another comma like so. So we have 2 here, and then we had 3. I'm not going to copy all of this. Let's do 74, and I'm going to do another 74 and another 74, like so. Press enter. We've actually created ourselves a tuple, but it doesn't often look like a tuple from first glance. And if I did test2 and then do a count of bar, like so, we should have 2 as the output because we have 2 values in this tuple set to bar. And if I was to do 74, that would come up as 3. Notice that I've mixed both strings and integers, and of course you can mix other bits and pieces as well. But what you can't do is you can't add things to the tuple once you've created it. So for example, if I did test2 dot add and I wanted to put in another 74, for instance, as an integer, so 74, like so, press enter, we have this issue. It says a tuple object has no attribute of add. We cannot add items to the tuple because it is a tuple, and by definition you cannot change it once you've created it. Also, I mentioned that tuples are indexed numerically, and we can find out the index of a particular value. So let's just do index like this, index of 74, and then we have 4. But as you've probably noticed, we actually have 3 values in this tuple set to 74, and the output here is 4. So what does that mean? Well, when we're calling index, we want to retrieve the index in which that value is found, and what it's doing is it's going through, it's iterating over the tuple. It's saying that that is at index 0, 1, 2, 3, and then it's found the first 74, which is at index 4, and therefore its output as 4. But just be aware that the values in your tuple aren't always unique, and therefore your indexes will be completely different, but the values will be the same. So here we have 4. If I was to do that again, but instead of 74 I put in the string of foo, that should come out as 0 as it has, because that is the first index, which is 0. So that's tuples. They're very straightforward. So let's focus on lists now. Lists, like I've mentioned, can be seen very similar to arrays in other languages like PHP or JavaScript or what have you, because you can start them off as completely empty, and then you can append or prepend things into that list or array of items. So for example, we can do test here. I'm going to do test3 is equal to an empty list. Press enter, and we can start adding things into this list. If I was to do test and then 3 dots and then tab a couple of times, we can see the methods available to us. So for instance, we can now do a append, and that is going to have a value. Let's just have put in a string of foo. Press enter. So we've now appended that value into the test3 list. And if I pressed up again, let's do bar, let's do let's just put in 1, and then let's put in 10, like so. Like with the tuple example, we can actually add items in this list that have already been added. So for instance, we can put in another 10, and if we did a count of 10, we can see that we have 2, because we have 2 items in this list that have the value of 10. But how do you go about discovering the contents of this list? Well, just simply type it, so test3 and then press enter, and here you can see that we have foo bar 1 and then 2 items of 10. Of course, we can reverse this list if we wish. We can do test3 dot reverse, like so. Now that isn't actually going to print anything out, but if we typed in test3 again, then we have what we had before, but in reverse. So we've actually flipped it around. So let's move on to the basics of using dictionaries. Now remember, a dictionary is indexed by a word, and the last example with the lists, we started them using the square brackets. With a dictionary, though, we use curly braces. So let's do test and 4, and we're going to equal that to an empty set of curly braces like so. So that creates ourselves an empty dictionary. And of course, if we did test 4 and then dot and a couple of tabs, we can see all the methods that are available to us. And very similar to the list object, we have methods such as clear and copy and pop and so forth that allows us to manipulate the dictionary that we've created. So let's go and add an item to this dictionary. To add an item, you need to remove the dot here and put in some square brackets. This is going to denote the index. And again, like I've mentioned before, the index is text-based, so put in some quotes. So let's go and add an index, and we're just going to have name, and then we're going to equal that to the value of Peter and then Fisher, like so. Press enter, and we've created our first item in the dictionary. Here we have the key, which is name, and we have the value, which is Peter Fisher. So we can actually retrieve the name if we did test 4 and then passed in the name like so. If we put in the index, that will return the value of Peter Fisher. And of course we can build this up. So for instance here, you could set this to, I don't know, perhaps job. For instance, we're going to equal that to the string of web developer like so. Press enter, and then now we have the job index. So if we did test 4 and then retrieve the job like so, that would return the string of web developer. One thing you can't do with a dictionary is you can't have two items that have the same index and value, because the index has already been added. So let's say, for example, test 4, let's have job, and let's set that to be, I don't know, mobile developer instead of web developer. If I was to set that, it has been set, but of course we haven't added anything to the dictionary. What we've done is we've overwritten the original value of job. So if I was to do test 4 and then retrieved that job index like so, it is no longer web developer, it is now mobile developer. So just be cautious when you're setting these things that you're not overriding something that has been previously added to the dictionary. We're going to be tackling lists and tuples and dictionaries in far more detail later on in this course, when we start looping over all of these variables to pull out and remove and replace the values within it, when we actually start building an application. But for now, though, I hope that has helped, and if it has, do let me know. If you've got any comments, questions, or queries, of course, put them down in the comments section below. I'll be interested to hear your thoughts, and also if you've got any suggestions for future tutorials as well. If you haven't done so already, please do subscribe, because I have a tutorial like this and a web chat every week. Thanks ever so much for watching. Happy coding, everyone. I'll see you again soon. Cheers. Bye. In today's Python for Beginners tutorial, we're going to be taking a look at comments. Comments are highly useful when writing code, regardless of what language you write it in. Comments will help other developers understand your thought process. It also means that you can comment functions and parameters and arguments and classes and all of that kind of stuff. We're going to use a IDE today, which is PyCharm from IntelliJ. I highly recommend it. It's a good IDE to use. So we're not going to be going through the command line today. If I go into the tutorial, you can see that this is the IDE that I have. We've got a comments folder, and that is in the GitHub repository. I'll put a link to this in the description down below. I've just created a simple Python file called tutorial.py. So this is our Python file, and we're going to talk through how to actually add comments to this file. So let's talk about the different styles of comments that we can have in our Python code. There's really only two types of comments. The first one is a single line comment, and the second one is a multi-line comment. each have their own symbols to denote what they are. So for instance, if we were to write a single line comment, that would start with a hash symbol. So this is a single line comment, like so. Of course, we can have multiple single line comments together. So we could have this is another comment, like so. And of course, we can have as many of these as we wish. Now, you may see Python code that has comments which have more than one hash symbol to start with. So, for example, you may have 3 hash symbols like this, or 2 or 3 or 4. It's really up to the developer. However, a single line comment such as this will be a comment because of the first hash symbol. So anything after that doesn't really matter. It's not going to be executed. It's not going to be ran by Python. So we could just put in another comment like so. Now notice PyCharm here has flagged this up. We actually have this brown sort of line underneath here. This is a warning. It's saying that there is no new line at the end of the file, so I just do that. That sorts that one out. But then it says that there's too many leading hash symbols for a block comment. Now this really is up to you. You can continue on as this. It's not actually going to break the application, but really what it's after is the removal of the second and third hash symbol. So if I remove those like so, then that's going to be perfectly fine. We no longer have the warning. So that's a single line comment, and of course I can split these up. I can actually start writing some Python between these things because these lines don't start with a hash symbol, so they will be executed in Python. But what about multiple line comments? Well, we start this off by using 3 quotes like this. Press enter and then we can write our comment within here. So this is called a multi-line comment, which means that we can have more than one line that is commented. So for example, we could just do this and then enter is a new comment, like so. So that will be commented out by the system. That line, this line, and of course this line will also be commented out by the system. Number 2, number 4, number 6, and number 14 are actually going to be what the system will run. Okay, so comments do not get ran by Python. And that means that you can also comment out lines in Python. So for instance, let's do print, and then let's do sort of hello and then world here. So that will be printed out. However, if I didn't want to print that out, if I wanted to comment that out, then what I would do is just put a hash symbol in front of it. Notice that that has gone grey here, and usually what you do is you put a space in between, and that will no longer be executed by Python. Of course, we can comment out more than one line, and you could also do this within multiple line comments like so. Now, these comments, they're not really that useful, and that's the whole point of writing comments. You need to write something that is useful to other developers, especially if you're using open source software. So let's make this a little bit more useful. Let's just remove that from now, put in this thing here, which is this will print hello world to the standard output. Right, so that's going to print that out to standard output. Let's remove that. And then let's do another print of hello world. And then put in this comment like so. So we're going to comment that out. And then put this will not be processed, like so. And then what we can do is just remove those. So we're actually writing comments that actually mean something. So this will print out hello world to the standard output, as we know, and this will not be processed because it is within a comment. Now, as I've mentioned and demonstrated, it's very useful to comment out code sometimes. So let's go ahead and start creating a list, add some contents to the list, but then remove some if needed. So let's do items is equal to a new list, like so. Now let's do items.append and then put in A, and then items dot append B, and items dot append, and let's put in C like so. So what we've done is we've created an items list and we've added 3 items to that, A, B, and C, all of which are strings. Now I have an error here. It's saying that this list creation could be rewritten as a list literal. We're going to be talking about that in more depth in another part of this course. Don't worry about that for now though. Now PyCharm, the IDE that I'm using, is fantastic because it also allows you to run Python code from a terminal within PyCharm itself. So that's what I'm going to do here. I'm just going to run this file, and as you can see at the bottom here, we have that printed out hello world, which is up here. So below the items here, I can now print those items like so. So items. Save that, and what I'm going to do is just rerun this. And in the terminal output, we can see that we have printed out this list, A, B, and C. Now what I'm going to do is just go back up to here and comment out B, like so. And let's just put in a new line like that, just to remove that warning. Let's save that and rerun this file. This is how you can comment out parts of the code, which will alter the behavior of the code when it's being processed, because obviously if you remove a line out of your Python file via a comment, then that isn't actually going to be processed. That's not going to be ran by Python because it is a comment. Now let's say I wanted to comment out the whole thing, so A, B, and C. So it is just an empty list. What I would do is I would remove that comment like so, and then I would add in 1, 2, 3 double quotes, then remove the last 3 and put them here like so. So what we've done is we've created a multi-line comment, and we've commented out all of these lines like so. If I was to save that, rerun here, we just have, can you see, just an empty list that we've created. A point that I just want to mention about using comments with the triple quoted string. Okay, they are strings, they're not technically comments. Yes, you can comment out code, yes, you can add comments and so forth, but they still get parsed like strings, which means that if you have anything syntactically incorrect within here, you're going to get an error when you run the code. Personally, what I prefer doing is having a single hash on each line to denote that that is a proper comment. I just wanted to demonstrate that you can use the triple quoted string like this. Just be careful though. Like I said, using a hash symbol is just far easier and safer if you're actually commenting out code. I use the triple quoted string whenever I'm starting a file, and I've got this right at the top where it's not actually messing about with any of the code, and it is just proper text. It's nothing that is going to damage the running of the application. So that is using comments in Python, and also a quick demonstration of some of the things you can do in PyCharm. With PyCharm, you can do a whole lot more than just the terminal stuff, which we're going to be using later on in other parts of this course. If you've got any comments, questions, or queries, though, on this tutorial, or if you've got suggestions for other tutorials and other courses that I'll do, then let me know. Put them down in the comments section below and I'll get back to you as soon as I can. If you haven't done so already, please do subscribe, because I have a tutorial like this every Tuesday, as well as a software development chat every Friday. Thank you ever so much for watching. Happy coding, everyone, and I'll see you again in the next one. Cheers. Bye. In today's Python for Beginners tutorial, we're going to be taking a deeper look into using strings. We're going to be creating strings, manipulating strings, and all sorts of other bits and pieces. So let's dive straight back in to the tutorial again. So the first thing we're going to do is just have a variable. We're going to call this s, and we're going to equal that to a string. So we could either use double quotes or single quotes. Let's just use single quotes for now. And the string value, we're just going to have, this is a test string, like so. Okay, so we've now created our string variable, assigned it to that variable value. Now we can actually play with the string object. Remember that I said that Python is very object based. And so a string is therefore an object, and we can call upon different methods on that string object to manipulate the value of the string. To call upon a method in an object, you simply put in the object variable and then a dot, and now you can actually call upon those methods. We're going to uppercase this string, so where it says this is a test string, that will all be in uppercase. What I'm going to do now is run this in the terminal within the IDE. So what I need to do now is actually put this as standard output, print this out to some sort of terminal. So let's just type print and then put in S like so. Let's save that, and what I'm going to do is just run this inside the terminal inside PyCharm. But notice that this hasn't actually changed. So this is a test string is just like this is a test string up here. We haven't actually altered how that is formatted by passing in the upper. So upper doesn't actually change the value, it changes the output. We're outputting S here. S is this up there. If we wanted to change it in the display, what we would do is copy that and put that into here like so. Let's save this and rerun this. So now we have this is a test string all in uppercase. So a point that I would like to make here is some of these methods on these objects, when you call them, they don't actually change the actual value that's stored in the variable. All they're doing is changing the output. So to recap, if I was to put this back in like so up here and then just print out S again, refresh this, we're going to get back to what the original value of S was. The reason why is because on line 2, where we're calling .upper, we're not actually printing that out. What we're doing is we're printing out S, which is at the original here, because upper doesn't actually transform that value. All it's doing is it's transforming the output of that value. So it's not actually setting it. If you think about it like a getter and a setter, all this is doing is getting that value and changing the output of that value to be uppercase. It's not setting that value to be uppercase at all. So let's put that back as this, like so. Run this again in the terminal, and as you can see, it has changed to this is a test string in all uppercase. So what we can do then is we can create another one, and instead of upper we can do lower like so. Hit save, run this again in the terminal. We should have two, which we have here. The first one is uppercase and the second one is all in lowercase. What I'm going to quickly do is just put in some comments. So here we have uppercase string, and here we have lowercase string as well. Case string. Now there is another one. There is also a capitalize, like so. Now if I save that and run this again in the terminal, what we've done here is we've capitalized the first character in this string. So we've got a capital T here, which is exactly the same as how the original is up here. Now if I was to put that down to lowercase and perhaps put that up to uppercase, for instance, save this, run this again in the terminal, this is still uppercase, this is still lowercase, and this has been capitalized, which means that the I of the is lowercase, and this character is uppercase, the first character in the string. So let's just grab this and put that in as a comment. So this is capitalized string, like so, and let's just move some of these down just to make a little bit more room. So we're starting to build up different ways that we can actually output this string. And of course, if I was to print the original string, which is just S, and press save, refresh this, then this is exactly how the original looks like. And this is probably a better way of explaining. These functions here, upper, lower, and capitalize, these don't actually modify the value itself in the sense that you're not actually changing the value. What you're doing is you're changing the output of that value. So when we print S again, it's going back to what it was set originally because it hasn't been reset in these other methods. Now the next thing I'm going to show you is how to trim down white space that's on either side of the string. So for instance, we could have two spaces here and two spaces like so. Now if I ran this again, you'll see that it's slightly pushed over to the right hand side here, and if I was to just drag that to highlight it, you can see that there's some spaces either side, here and here, like so. It's not easy to see here, but what I can do is actually remove the white space. And what we're doing is we're stripping the white space out. To remove the white space, what I would do is type print. In the print parentheses, have s, and call upon the method called strip, like so. Let's save that, return this now, and can you see that this one here has been stripped of all white space, whereas this one here and these three up here still have white space on either side. So we are stripping that out. These objects also allow you to chain the method calls. So for instance, if I wanted to strip out all the white space here, but I wanted to also call upper, then I can do so by chaining these methods together. So after this strip, I can now do upper like so. Let's hit save, refresh this, and now we have this that is stripped of white space, and it's in an uppercase format as well. So just for clarity, what I'm going to do is just add some comments here. So this strips white space and uppercase, like so. Now the next thing I'm going to demonstrate is how to actually find characters within a string. This is called finding the substring, a substring within a string. So for instance, up here where we have this is a test string, we might be wanting to find the position of, say, the first T, or the position of this string, the substring within this string. And we can do this by printing this out, so print, and we use the s.find method that we're going to call upon. Now the find method requires one argument, and that is the substring that we wish to look for. Again, that's going to be a string, so it needs to be as a string, but it has the start and end positions as well. We're going to talk about that in just a second, but let's just put in the find method, and let's just put in the substring that we wish to find of just t. Rerun this, and we can see that we have the output of 2. This means that this is at the position index of 2. If we go up here, we can see that we have white space, 2 pieces of white space, and that would start from index 0 and then index 1, and then the t would be index of 2. So we found t at position 2 within the string. This is the substring that we're looking for, which is t. Now if we were to change that to be test, so test, save that, refresh this, this is actually going to get position 12, and that is this position up here. So within this string, that is the 12th character within this string, the 12th index of the string. Now I mentioned before that find also has 2 optional arguments. One is the start and one is the end. This means you can actually sort of narrow down whereabouts in the string you want to find the substring. So for example, just going back to t and then hitting save, rerunning this, that will come back with 2, and that is because it's hit the first one. But what happens if we want to find this one? So we're not interested with the first word here, so we're interested in anything after the index of, say, 3. So let's put in the start position of 3, and let's put in a space between the 2, hit save and rerun this. We can now see that it's picked up the t of test. All right, so this is at the 12th position. What about finding t in this position, in the substring of the text string? So let's just change that to be 13, for instance. Save that and rerun this file. We can see that that's come out as 15 because that is at the 15th position. And again, what I'm going to do is just put in some comments. So find substring starting at position 13, like so. Okay, for this next part, what I'm going to do is actually find the length of the string, but before I do that, I'm just going to move some bits and pieces around in the IDE so you can see it a little bit better. So what I'm going to do is just move the terminal here over to the right and then drag this over here so you can see a little bit more of what I'm doing. I'm going to put all of this in the GitHub repository, and I'll provide a link to that in the description below. Let's now continue with this tutorial, and let's go and count the length of this string. And we do this using the len function, len meaning length. So let's say we want to print, so let's do a print of len, and we're passing in s. So that's going to return the length, the size of this string. Let's save that, run this again, and we should have 25. This is saying that there's 25 characters within this string. Now with these strings, we can return a portion of the string, the substring if you will, based on its index. Remember I said that it starts from index 0, much like a list does. What we can do is actually print out the character that is at a particular index. We do this by just typing in print again, and instead of just putting in s, we actually put in open brackets like this. Now we know that we can find t from the starting position 13, and that returns an index of 15. So if we were to put in 15 here and then hit save, rerun this, we should have t that's being returned. So that's returning the part of the string that is at position 15. Not only can we return one character in the string, but we can also return a set of characters within a substring. We can define the start positions and the end positions. At the moment, this is the starting and end position. If we were to put in a colon like this and then put in, say, I don't know, 20, for instance, save that, run this, we're going to get t and then str. This is the start of string. So that is the t that we've got, and then str. If I was to remove 15 and say, let's say that was 11, and move that to 15, for instance, hit save, run this, then we're going to get tes, the start of test. If I was to change that to be 16, we're going to get the whole word of test. We're also getting some white space as well, because can you see it's indented a little bit to the right. So let's go and actually carve that up a little bit. So this should be 12. So 12 to 16 should return just the word test, or just the substring test. If we supply an end position that is bigger than the index of the final character, so let's say that was I don't know, 1000 for instance, and hit save, what we're actually going to do is just return everything up to the last part of the string. So let's just hit return, and so we have this is a test string, and of course we've got the white space as well. So even though we've asked for position 1000, our characters don't go that far, so it's truncating the return to the last part of the string. Also, what we can do is omit both of the end position and the start position, so we just have a colon on here. If we hit save and return this, that is going to return the whole string from the start to the end. So what I'm going to do here is I'm just going to put in some comments. So this finds the length of the string, and I'm going to put this back to, I think it was 12 and I believe it was 16, the substring starting at pos 12 ending and ending at pos 16. Okay, so the next thing I'm going to show you is how to actually replace parts of the string. So what I'm going to do is just change this a little bit. So instead of this is a test string, I'm going to change this to be I like cats. Okay, let's just remove that white space, or let's just keep it in because we are stripping that out. So let's run this again and let's see what happens. So we have I like cats in uppercase, I like cats in lowercase, we've capitalized this one, this is in uppercase, and we also have a -1. Now this is happening because we don't actually have a character at position 13. If I was to change that to be 5 and then ran that again, that will be updated to position 9. So let's remove that from the comment to be position 9. Let's hit save. We can also see that we have a blank output here. This is from this print. So what we're going to do is just change that to be 5 and then 10 like so. And we're just going to change this as well. Let's save that, run this again, and we now have E and cat. I'm going to just change this to be 7 like so. Okay, so what we're going to do now is replace the word cat with the word dog. So what we're going to do is just run print again, and we're going to do s, and we're going to call upon the method replace of the string. And the first argument is the old string, and then the second one is the new string. That is the new string that we wish to replace the old string with. And also we can supply a count if we wish, so just in case there's more than one thing that we want to replace, it will replace 1 by default. So let's say we want to replace the string cats with the string dogs like so. Let's just hit save, run this, and what we're going to see is I like dogs instead of I like cats. To finish this off, what I'm going to do is just have a comment in here. So we're going to just replace string cats with dogs like so. And what I'm going to do as well is just move that final print right to the bottom, because that is printing out the original S value, which is just I like cats up here. Let's just run this again, and there we go. So that's the original. This is the uppercase, lowercase, and so on and so forth. These are the counts, and this is the replacement. Now there are other things that we can do with strings, such as concatenation, such as converting these to a list, so we have a list of all the characters within a string, that kind of thing, and lots of other bits and pieces too. I'm going to be doing those in individual tutorials within this course. But if you've got any comments, questions, or queries on this tutorial or on any other tutorials or courses that I've done, please put your thoughts down in the comments section below, and I'll get back to you as soon as I can. If you haven't done so already, please do subscribe, because I've got tutorials like this every week, as well as the software development discussions as well. Thanks ever so much for watching. Happy coding, everyone. I'll see you again soon. Cheers. Bye. In today's tutorial of the Python for Beginners course, we're going to be taking a look at numbers. So let's dive back into the IDE, which is PyCharm, and let's start creating some numbers. Now, the first thing to note is Python sees 4 different types of numbers. The first one is an integer. Now, this is a whole number, whereas a floating point is a decimal. So that's where you have a dot, where you've got 1.5 or 2.6 or what have you, or pi, for instance. Now, integers can also be negative, so you could have a -1 or a -2. So, for instance, this here, if I did a print of 1, that is an integer. If I did a print of -1, that is also an integer. And of course, if I did a print of 1.5, that is a float. Python also has another type of integer, and that is called a long or longs. This is an unsigned integer, which means that it has unlimited size, so it can go for infinity. The next type of number is a complex number, and this takes the form of a plus b j. What we're going to do now is convert these different types of numbers. Let's just remove this for now. Let's create a variable and assign that. Let's do n. Let's assign that to 1.5, for example. So what I'm going to do is cast this to an integer, and we do this using int like so. This is an int method, and we're just going to pass in n. Now what I'm going to do is just print that out, so I'm going to put print like so. Let's save that, and I'm just going to quickly run this. So that's output the value of 1, even though that is 1.5, because what we've done is we've converted the float of 1.5 to the integer of 1. I'm just going to add a comment here. We're just going to have convert to int. The next thing I'm going to do is convert an integer into a float. So let's do y and assign that to the value of 1. So that's an integer, that's a whole number. And then let's do print float and passing in y like so. Okay, let's save that, refresh this, and now we have 1.0. It was 1 to begin with, but now we've converted it into a float, and therefore it's 1.0. If that was 10, and save that, refreshed, then that would be 10.0. So up here, I'm just going to add convert int to float, and we're just going to put that comment above there as well, like so. Save that. Good. Now with complex numbers, what we can do is just have, let's do, I don't know, x, and let's set that to be 15, for instance. Let's now do a print, and again, just pass in complex, passing in the y or the x argument, I think it was. Yep. Let's save that, refresh this. So what we've done is we've converted x to be a complex number, and the output here, 15 plus 0j, means that 15 is the real number, and we're plussing that to, as I mentioned before, b, which is our imaginary number. With complex numbers, you can also supply a second argument, so we could also have y in here. And what that's doing is it's creating a complex number with both x and y. If I save this, we'll see that we have 15, which was x, plus 10, which is y, and j. So basically what we're doing is we are expressing the solution of what x plus y is within a complex number. Now, a complex number is a combination of a real number and an imaginary number. So that's how you can create and convert types of numbers in Python. Later in this course, we're going to be doing some math with numbers, so it's very useful to understand the basics and the types of numbers before we get to that point. If you found this tutorial helpful, if you've got any questions, comments or queries on this tutorial or any other tutorial that I've done, then let me know. Put your thoughts down in the comments below. Also, if you've got any suggestions for future courses or tutorials that I could do. If you haven't done so already, please do subscribe, because I've got a tutorial like this as well as a software development chat every week. Thanks ever so much for watching. Happy coding, everyone. I'll see you again soon. Cheers. Bye.